Hi, it's Jan Beta, and we're going to take a look at a very silent SID today. This is the Commodore 64 board I repaired in the previous episode, and I got everything working except for the sound. This is the famous 6581 SID chip that is the sound chip in the Commodore 64. And while this chip is alright, I did get a very low volume output on the connector here, which should output the normal, basically line level sound. And it just didn't. It is audible, but it's very faint and very quiet. So I assumed that there would be something wrong in the circuitry surrounding the SID. The SID itself works fine. I tested it in another machine. It's loud and clear and all the channels seem to work. The pedal inputs, which are also handled by the SID, worked. So I just assume that this chip is alright, but it doesn't output sound in this machine. So I did some troubleshooting and I measured the continuity between the output pin from the SID. I measured the input voltages for the SID and everything seemed to be alright. I replaced a little resistor here that I suspected to be kind of wonky because it looked a bit burnt on one side, but turns out that didn't fix it. Then I went ahead and also replaced this transistor here, which is amplifying the signal normally, and that didn't change anything. There are not too many components between the SID and the output, so we are going to take a look at the schematics and figure this out. Yay, schematics time! These are hand-drawn, but not by me. This is a printout of the original schematics that I don't know who actually drew these, but these are the original Commodore schematics. You find these in various PDFs scattered around the internet. I'm going to link a particularly nice one in the video description. You also find these in the Commodore 64 reference guide, I believe, these old schematics. Let's look into what we have here. This is our SID chip that we've seen, 6581. U18 is the place on the board. The silk screen says U18. And I assume this stuff here is all good. These are our voltage inputs. We have connections to the data bus, of course, the address bus. These capacitors here are set according to the SID model. And we have a ground connection, of course, reset, chip select, timer, phi, which is the dot clock, I think. Yeah, it's connected to the dot clock on the VIC-2. And I think there's nothing really wrong with that. Interestingly, in case you didn't know, this also has an external input that isn't really used by much, but it is integrated in this integrated circuit. So the SID actually has an input. But what we are interested in is the audio output. That is on pin 27 and it goes through a ferrite bead here, which is just basically an EMI filter. It filters out really high frequencies and noise, which is a good idea. Then we have R7, a 10K resistor that is connected to C37, that's a 1000 picofarad capacitor. And in case you watched my Amiga 3000T audio episode, this might look familiar because it is a low-pass filter. In this particular setup with the 10K resistor and a 1000 picofarad capacitor, it starts filtering at around 15 kilohertz. So that's only filtering out very high frequencies. I don't think I can hear 15 kilohertz anymore, but human hearing usually goes to around 16 kilohertz. So this just filters out more of the inaudible noise, basically, because the SID, I think, goes to around 3 or 4 kilohertz. At the most is what it can put out at all, so this just filters stuff that you can't generate with the SID anyway. Then we have our little transistor. That's an NPN transistor, 2SC1815. That is used to boost the signal for the audio output. Of course, has a voltage input, plus 12 volts, and is connected to ground here. There's another little filter capacitor here, I think, but only to filter out high frequency stuff. Again, EMI, that's C205, and that is the one that's soldered on top of this resistor. We're going to see that in a bit. And then we have C13, that's an electrolytic capacitor that's coupling the amplified signal to the audio out. That basically just filters out DC voltage from the output that was amplified. So you get a nice amplified, clean signal on the audio output from the original audio output on the SID. That's what all this does, basically. And there are a few things that could be broken, of course. I replaced this here, R6, that's already replaced. That's a 1K resistor. If that gets shorted, of course, the signal is just going to be pulled to ground, because this is just going against ground. Might be that the ferrite bead got damaged, but I don't think so. Usually these last forever. We're going to check the other resistors here. We're going to check the capacitors. I already replaced this Q8 transistor. And I would also check the C13, of course. And then another thing I can think of that could cause the signal being low here on the output is, of course, the DIN socket being slightly worn out. So we're going to have to check that, if there's good continuity from the DIN socket to maybe this capacitor, something in the circuit actually, to rule that out. And there's another thing that could go wrong, and that is that our audio signal forks off here. That's connected all the way to our RF modulator. And if something shorts to ground there, or something like that, there are capacitors in here and things like that that could potentially go bad and just pull down our audio signal. And that would, of course, because it's just directly connected here, would of course also cause the audio output to be low. So lots of things to check, but not undoable. And I'm pretty sure it could be something completely different, but after everything I checked already, I'm pretty sure it's just one of these components here, or the RF modulator, that is broken. Let me take a few seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They can also do CNC machining, 3D printing, sheet metal fabrication, injection molding. They can populate your boards for you. The quality of all those products is excellent and the pricing is super reasonable. Delivery is fast. They are friendly people to work with. So I highly recommend checking out the link in the video description in case you're interested. Back to our sound issue. Okay, enough schematics for now. Let's look at the actual board and see if we can check things in situ. Some of these things are obviously not going to be that easy to check in circuit, but I'm at least going to take a look at our R38. That's the one that has the capacitor soldered over it. That should be 1K, which it is, yay. We replaced the transistor here. You can also measure capacitors in circuit by just measuring the resistance often, or at least tell if they do something. So let's check this one. And the resistance should be rising slightly while it charges. Yeah, which it does in this case. It's a very small capacitor, but we can do the same on the electrolytic capacitor. That should rise a bit more, I guess. So that's our capacitors. And we also have R7. That should be this one here. And that should be 10K, according to the schematics, which are pretty accurate so far. 9.899K. Good enough for me. So that all seems all right. Let's see if we have audio output on the connector actually. So and for that, I'm going to unplug it from our upscaler here. Yeah, I'm just going to measure the audio RCA plug here and see if the signal comes through from the negative side of our capacitor. Yep, that's 0.5 ohms with all the cable in the way. So our connector is good. Our resistors that are in the way seem to be good. I didn't take a look at the RF modulator yet, but maybe we don't have to. It might just be the electrolytic capacitor in here. That measured a bit strange. Let's see if we can measure the capacitance. I did measure the resistance and it did rise a bit, which is what it normally does if the capacitor is charging up in some way. Let's see if the capacitance reading here gives us something. Yeah, not much, but that might just be because it's in circuit. Let's see what the other one says. The little one here. Little ceramic. Yeah, this is in circuit, and this is not made for measuring stuff in circuit at all. Let's try something that is made to measure stuff in circuit and see if that helps. So I got my fancy ESR 70 ESR meter out, and we're going to have to do this from the back side, I think. This is our electrolytic capacitor. Just going to touch my probes to it. And this should be able to... Oh, okay. This should be able to measure things quite accurately in circuit normally. It says the ESR is over 40 ohms. That's not good. That's not what a working capacitor says normally. ESR should be way lower than that. So yeah, I think that's the first thing I want to replace. That's our coupling capacitor. That's the last thing in the line, C13 here. That's between the audio out and the output from the transistor. If that is broken, that's going to pull our signal way low. Let's pull that. That might be our culprit. But of course, there might be more things wrong with this. But this didn't look good. And it might actually explain the behavior. I guess, contrary to popular belief, capacitors in a C64 can actually go bad, which is not really news to me because I replace them all the time. But very few of them are actually bad. So let's see if this one is. Oh, it doesn't even see the capacitor. Normally this would trigger. Okay, this one, it is hooked up and it doesn't even see it. That's bad. Let's try with the one that I was going to put in there. This should see this right away. Yep, that's a good 10 microfarad capacitor. 4.2 ohms, as opposed to not showing up on the meter at all. So yeah, this is toast. And I hope that was the whole problem. But this would explain this and make this a full repair after the 3/4 that I did last time. That might have been the whole problem. Let's see if that did anything. Yeah. That was the whole issue. So I guess it would be a good idea to replace all the little electrolytic capacitors on the board. The SID seems to be absolutely fine. The rest of the board seems to be absolutely fine. So that was the problem here. If there's a problem in the RF modulator, that might be a bit more tricky because there are quite a few components in there. And if you don't need an RF modulator, I would suggest, if you have this problem and you have ruled everything else out and it is the RF modulator, I'd probably either cut the audio connection to the RF modulator, which should help, or just replace the RF modulator with one of the modern replacements. Very few people use RF. I'm one of the people that uses RF output from time to time, so I usually leave these in. But if you have this problem and you don't need RF, you might as well just replace it with one of the modern replacement boards that don't generate RF output, but result in a better video and audio output in general for the composite and S-video outputs. Yeah, that was a quick one, but that's how it goes sometimes. So this C64, I'm probably going to do some future-proofing stuff with it and put heatsinks on all the chips and replace the rest of the capacitors. Usually if you have more than one of the same brand of capacitors and the same size, they often go bad at the same time, basically, because they are usually from the same batch. There are a few other things that you might want to check that I didn't show in this video. I did that in the last video. Check the supply voltages for the SID. For the old 6581s, that's 9 volts and 12 volts. And for the newer ones, it's 5 volts and 9 volts for the 8580. And you also want to check the sockets and the connections from the chip to the rest of the circuit, because those sockets that Commodore used in the C64 are often of very bad quality, to put it mildly. And this is no exception, but this socket seems to have held up fine over the years. Yeah, that's it for today. Thanks for your time. Hope you enjoyed this and hope it helps fix more C64s. Special thanks, as usual, to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. And if you want to give me some support, the links to that are in the video description and on my website. That's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.